now that we've had a chance to see the main set operations you're going to be working with, let's take a shot at a slightly more involved example. So we are given the sets U as the natural numbers less than 10. A is the odd natural numbers in that range other than 5, so 1, 7. B is 3, 7, 8, and 10. And our goal here is to use these sets to run a couple of set computations. What I'll say for this type of problem is whenever we're trying to perform set operations, we should always start from the inside and work out. Kind of like with the order of operations for algebra, you always start with what's inside of parentheses and then work outward from there. We're going to do the same thing here. So if we want to find A intersect B complement, we can start by finding A intersect B. We're looking for A intersect B. We want the set of things that are in both A and B. Let's start this out writing long form. Let's make sure we know all of our options here. We have 1, 3, 7, 9, and we are intersecting that with the set 3, 7, 8, 10. So what we want to do is identify what is in both of these, where here we can see that 3 and 7 are both in there, 1 and 9 is just here, 8 and 10 is just there, so our intersection would end up being, not my best curly brace, that's okay, 3 and 7. So our next step, we go a step outside of that, and find complement of that. The complement of A intersect B is in this context the complement of the set 3, 7, which would be everything in the universal set other than 3 and 7. Can be a whole lot of things. That is going to end up being 1, 2, 4, 5, 6, 8, 9, and 10. It's going to be everything other than 3 and 7. It's the complement function. So our other step is to find the other pair. We want to find the other one, the A complement union B complement. First thing I do is start on the insides, find those two complements. So for A complement, we're looking for everything but 1, 3, 7, and 9. Oh, I said union, excuse me. Anyway, that would be the sets 2, 4, 5, 6, 8, and 10. While B complement, if I were to stand in the way of the example, would be set 1, 2, 4, 5, 6, 9, and 10. So if we have these two and we take their union, we're looking at anything that's in either of them. So A complement, union B complement. We just take all of our options here. We've got 1, 2, 4, 5, 6, 8, 9, and 10, which incidentally, write that out, 2, 4, 5, 6, 8, 9, 10 is the same as that right there. This is the same as A intersect B complement. And this hints at a very important property that we're going to see in 2.4, which is called De Morgan's laws, which tell us about something what happens when we try to negate or reverse unions and intersections. But we'll see that near the end of